Hello, grade 12s. In today's lesson, we're going to be looking at organic reactions and we are tackling question 4 prelim free state 2020 and let's get right down to it. So we have question 4. It says the flow diagram below shows how a haloalkane compound P can be used to prepare other organic compounds. The letters A to F represent different organic reactions. Now we can see our flow diagram there. Now 4.1 says, is compound P a primary, secondary or tertiary haloalkane? Give a reason for the answer. Now before we can give an answer to that one, let's check and understand what are primary, secondary or tertiary haloalkanes. Now we say a primary haloalkane is whereby the carbon that is bonded to the substituent is only bonded to one other carbon. Then for secondary is, we say the carbon that is bonded to the substituent is bonded to two other carbon atoms. Then for tertiary, the carbon that is bonded to the substituent is bonded to three other carbon atoms. So that's it. Now let's go back. Is this a primary, secondary or tertiary haloalkane? Now the carbon with the bromine is only bonded to one other carbon atom, right? So this makes it a primary haloalkane. Why? Because the carbon with the substituent, which is bromine, is bonded to only one other carbon atom. Now 4.2 says, write down the IUPAC name of compound Q. Now we can see Q here is an alkene, right? But it comes from reaction A. We know that this reaction must maintain the same number of carbons all throughout. So if this is a compound with 3 carbon atoms, that means here we have an alkene with 3 carbon atoms. Then the IUPAC name is prop-1-ene or propene. .3 says state 2 reaction conditions for reaction F. Now we can see that reaction F is moving all the way from the haloalkane to form an alcohol. Now we know this is substitution reaction because we are moving from a saturated compound to form another saturated compound. But now, what is the name of this substitution reaction? Because we are forming an alcohol, we say it's hydrolysis. Now, what are the reaction conditions for hydrolysis? We know we need excess water and mild heat. Now 4.4 says compounds R and S are structural isomers. Define the term structural isomer. Now what are structural isomers? We say structural isomers are organic compounds with the same molecular formula but different structural formulae. Now 4.4.2 says, are compounds R and S positional, functional, or chain isomers? Now let's look at compound R. See, compound R is propan 1-ol. But for S, we have an alkene here reacting with H2O water to form an alcohol, right? Now we know according to Markovnikov, this alcohol here that forms must have the OH group in the second carbon in order to form the mature product. So this makes this compound in S or compound S propan 2-ol. Now compound R is propan 1-ol and compound S is propan 2-ol. Are these positional, functional or chain isomers. Now we can get from that they will have the same molecular formula, but now what is different? It is the position of the functional group. The OH group in R is in carbon number 1 and the OH group in S is in carbon number 2. So this is positional isomers. Now 4.4.3 is asking us for a reason now. Give a reason for the answer to question 4.4.2. So that is just a definition. We say because they have the same molecular formula but different positions of the functional group. Now 4.4.4 says write down the structural formula of compound S. Okay, I think I've already done that. So let's draw the structural formula. 1, 2, 3. But remember we said the OH will be on the second carbon. Four point five says write down the name of the addition reaction B. So B, we are told it's addition reaction. Now we know for addition reaction it's USA. From unsaturated to saturated, that's addition. As we can see here in B, the alkene is unsaturated. It's moving all the way to a haloalkane, which is saturated. Now they say write down the addition reaction B. What type of addition reaction is this one? We are forming a haloalkane, so it has to be halogenation. Now 4.5.2 says write down the name of the elimination reaction D. Now for elimination reaction, you will remember we have two. From saturated to unsaturated, it's elimination. Now we can see we are moving from alcohol, a saturated compound, to alkene, an unsaturated compound. Now what is the type of elimination reaction here? Because from alcohol to alkene, we have to remove water. We say this is dehydration. 4.5.3 says write down the name of the substitution reaction F. Now in F we can see that we are moving from a saturated compound, haloalkane, to another saturated compound, an alcohol. Saturated to saturated, that's substitution of course, but what type of substitution is this? Now we are taking a haloalkane and we are forming an alcohol. We call that substitution reaction hydrolysis. 4.6 says using structural formulae, write down a balanced equation for reaction E. Reaction E. I'm talking about this reaction here. We are moving from an alcohol back to the haloalkane. Now our alcohol is propan 1-ol. So let's draw propan 1-ol. So we have it like this. Then react that with hydrogen bromide. Then we obviously gonna have this. So where there is OH, where there is the hydroxyl, we now substitute the bromine. Now when this OH goes out here, it will react with the hydrogen atom to give us H2. So the hydrogen ion here, and then to give us H2O. Awesome.